In this lecture, we're going to take a look at the anatomy of the foot and the ankle. There will be some structures that we will review here that I will want you to review during the practical session for our surface anatomy palpation. We're going to start by looking at the lateral aspect of the foot. We have the lateral malleolus, the talus, the calcaneus, the cuboid, the fifth metatarsal, and the fourth metatarsal. The calcaneus, cuboid, fourth, and fifth metatarsal make up the lateral longitudinal arch of the foot. If we add the ligaments to this diagram of the bones, here we have the anterior talofibular ligament. Here is the calcaneofibular ligament. Then we go into the calcaneal talar ligaments. This is the lateral talocalcaneal, the interosseous ligament, and the cervical ligament. The latter two are found deep within the sinus tarsi, and we are unable to palpate those with our surface landmarks. The other ligaments that are shown here, there are various ligaments running from the cuboid, some to the navicular, some to the cuneiforms, metatarsals, and to the calcaneus. The names for those ligaments are named by termed by the cuboid and the bone that ligament is attached to. Becoming a little bit more superficial, we're now looking at some of the key muscular structures. This is the tendon of peroneus longus and the tendon of peroneus brevis. These are the primary everters and plantar flexors of the foot. This is extensor digitorum brevis and the muscle belly of extensor digitorum longus, and you can see the tendons on top of extensor digitorum brevis. This is abductor digiti minimi, and then we have some retinaculum on the lateral aspect of the foot. This is the peroneal retinaculum, which helps to hold the peroneal tendons down, and this is the extensor retinaculum, helping to hold the extensor tendons down. Now if we move over to the medial side of the foot, the key bones here, this is the navicular, first cuneiform, and the first metatarsal. The other key bones would be the talus again, and then we have the medial malleolus made up from the tibia. If we add the ligament structures, here we're looking at the anterior tibiotalar ligament. This is a portion of the deltoid ligament. This is the tibionavicular ligament, dorsal navicular cuneiform ligaments, and this would be the dorsal cuneiform metatarsal ligaments. One ligament that we can't see in this dissection is the spring ligament, which goes from the navicular tuberosity to the sustentaculum tali and supports the head of the tibia. Let's take a look at the key muscular structures on the medial side of the foot. This first tendon is tibialis posterior. It attaches to the head of the navicular and then underneath the surface of the foot to the majority of the bones there. This is abductor hallucis, tibialis anterior, and the flexor retinaculum that covers that tendon. This is flexor digitorum longus and flexor hallucis longus. And this last is just to remind us that underneath that tendon of tibialis posterior is the spring ligament, which is attached to the navicular but supporting the head of the talus. In this slide, we're looking at the posterior aspect of the foot. This is the posterior talofibular ligament, which is taught in maximal dorsiflexion and inversion. And here we have the posterior tibiotalar ligament, which is taught in maximal dorsiflexion and eversion. Here we're looking at the bottom of the foot. First ligament that we're looking at is the short calcaneocuboid ligament. The next is the calcaneonavicular ligament. In between As we go a little bit deeper, this is just showing peroneus longus as it comes around and attaches to the base of the first metatarsal and the navicular. And the second is tibialis posterior, which you can see has branches that fan out to the majority of the midtarsal. In this next slide, we're looking at some of the deeper intrinsic muscles of the foot. This first one is the lumbrical muscles in between the metatarsals. This is abductor digiti minimi, abductor hallucis, and this is flexor digitorum brevis. Here we're looking at the most superficial portion of the foot, which is the plantar fascia. The plantar aponeurosis is generally regarded as a modification of deep fascia. It is a dense fibrous structure lying immediately deep to the subcutaneous fat of the sole of the foot. It spans the entire length of the sole proximally. It is attached to the medial and lateral tubercles of the calcaneus, and proximal to these attachments it is attached to the inferior aspect of the posterior surface of the calcaneus, just below the insertion of the tendocalcaneus. Distally, the plantar aponeurosis divides into 5 slips, one for each toe. The plantar aponeurosis is composed mainly of longitudinally disposed fibers within a smaller proportion of transversely disposed fibers. The central portion of the length of the plantar aponeurosis is a tough and thick band of tissue. It lies superficial to the flexor digitorum brevis muscle. The medial and lateral portions of the plantar aponeurosis are relatively thinner than the central portion and lie superficial to the abductor hallucis and abductor digiti minimi muscles respectively. The 3 portions of the plantar aponeurosis are coextensive. Arteries on the medial aspect of the foot. This is the dorsalis pedis artery, which is going to supply the structures on the dorsum of the foot. This is a communicating branch of the peroneal artery, and this is a perforating branch of the peroneal artery, which provides some anastomosis to the dorsalis pedis artery. On the medial side of the foot, our major artery is the tibial artery, and as it goes through the tarsal tunnel, will split into a lateral and a medial arch supplying the structures of the sole of the foot. Let's look at some of the neural structures on the lateral aspect of the foot. This is the sural nerve, which is a branch of the tibial nerve. It is a sensory branch that supplies the lateral aspect of the lower leg and the lateral aspect of the foot and ankle. This is the superficial peroneal branch, which is primarily a cutaneous branch. And then we have the deep peroneal nerve, which supplies a number of the muscular structures on the dorsum of the foot. If we go to the medial aspect of the foot and ankle, the primary nerve structures are the tibial nerve, which branches into the lateral plantar nerve and the medial plantar nerve. Both of these nerves can be stressed through our straight leg raise using dorsiflexion and eversion. For the medial, we're going to extend the first 3 toes, and for the lateral, we're going to extend the 4th and the 5th toes. Talk about what the primary functions of the foot are. The foot is basically a rigid mobile adapter. So at heel strike, it goes from being a rigid structure, and as we move into mid stance, it becomes more of a loose adapter. One, this is to help provide some shock absorption for the lower limb and the foot and ankle as we put most of our body weight over top of the foot, but it also allows us to accommodate to uneven terrain. As we move further through the gait cycle, the foot will move away from being a loose adapter to becoming more of a rigid lever. And as it becomes a rigid lever, this will provide effective heel off and a nice rigid base to be able to push off through the distal end of the foot. The last thing that it does is it helps to absorb transverse plane. There's a couple of models on how the arch of the foot is maintained in a weight-bearing position. The first is the beam model, which is concerned mostly with the architecture of the bony structures. You can see in this picture that the shape of the metatarsals, the cuneiforms, and navicular, especially the mid-tarsal bones, have sort of a wedge-shaped look to them. And when you put the calcaneus, mid-tarsals, and the first MTP together, if you have weight pushing downwards, the bony anatomy basically creates a nice stable arch. The truss model is more concerned with the soft tissues of the foot. The plantar fascia and the muscular structures on the sole of the foot, by their attachments, when we have load being placed through the lower limb, we will get a flattening of the foot, which increases the tension in these soft tissue structures. The increase in tension helps to provide support for the medial and lateral longitudinal arch. The last mechanism that I want to talk about is the windlass mechanism. You will hear this again in the gait lecture, and if you haven't listened to the gait lecture, we'll talk about it here now. The windlass mechanism involves the plantar fascia. When the foot is in the pronated position, the plantar fascia is providing some support for the medial and lateral longitudinal arches. As we move through supination, so getting near the end of mid-stance, starting to heel off, and now going into toe-off position, the extension of the metatarsal phalangeal joints increases the tension in the plantar fascia, which helps to further strengthen and make the mid and forefoot more rigid. That makes it a much more effective lever for push-off during our gait cycle. This ends the end of our anatomy review for the foot and the ankle.